I'm just going to talk through this question about radiation, and it's a tricky question for students to answer because it asks a question about a new context we may not have covered in the classroom. But with a little bit of thinking about it and applying the knowledge that we do know, it's actually quite a simple question, quite easy to score all 6 marks. So the question starts out like this. It says, a removable lens from an old camera has got 4 pieces of glass in it. We can just see a picture of the camera there and this removable lens. I'll just scroll down so we can see the rest of the question. It says, one of the pieces of glass is radioactive, and that's this one shown here. It's covered with a thin layer of magnesium fluoride. The radioactive isotopes in this glass emit alpha, beta, and gamma radiation in all directions. So coming out of this glass is all of the types of radiation mentioned. A scientist removed the lens from the camera. She puts the radiation, she measures the radiation coming from the back, here, the front, here, and the side. The amount of radiation is different in each direction, and you can see that by the numbers: 720 becquerel, 110 becquerel, and 105 becquerel. It says also importantly here, no alpha radiation is detected. Now, we know from our knowledge this kind of familiar diagram where alpha radiation, shown here, is kind of absorbed by paper and also by air. Beta can be absorbed by aluminium, doesn't get past, and gamma basically passes through everything, and even a little bit will pass through some thick lead. So this question is testing our knowledge about this information just in this new context. So we can see here at the back the radiation is just coming through, so at this stage maybe I'll have alpha, beta, and gamma, as there is nothing to stop that radiation. And at the front here, there are the numbers much smaller, and maybe the glass is absorbing some of the alpha and beta, so we only get gamma. And then similarly, the thick aluminium is able to absorb the alpha and the beta, so here you only get gamma. Now I do need to check my question, because here it does say no alpha radiation is detected, so the alpha radiation at this part must be being absorbed by the air gap in between the detector and the radioactive glass. So that's the information I've got. So now the question says, explain why the readings in the 3 different parts are different. So I need to talk about the front, I need to talk about the back, and I need to talk about the side. And if I'm setting out my answer, I already know I need to talk about these 3 things, so I'm setting it out, leaving some space in between, using up all the space I'm given for the question, and kind of starting my question answer out in bullet points, which is absolutely fine. At the front, looking at this information, I've only got 110 becquerel. 110 becquerel. At the back, I've got 720 becquerel, and at the side, I've got 105 becquerel. So I need to explain what's going on at each of these stages. So at the front, the alpha must be absorbed by the glass, which I had at the front of the lens. I've also got beta must be absorbed by the glass as well. So I've only got gamma detected. At the back, 720, well here I've got beta and gamma, so I can say similarly the alpha is absorbed by the glass, and the beta and the gamma is detected. And finally at the side, I've got this here, the gamma getting through, so I can similarly write the alpha is absorbed, and in this case is by the thick aluminium casing of the camera. by the thick aluminium. Similarly, the beta, well, is exactly the same. That's also absorbed by the thick aluminium, and only gamma is detected. So this kind of describes what's going on, explaining why the reading's a little bit different for the front, the back and the side. To completely explain it, perhaps we need to add some information about I think that's a 6-mark answer now. We've set the question out as front, back and side, describing why the values are different and explaining why they are different about gamma being detected and the alpha and beta being absorbed by those different thicknesses of materials. Going back to the question, we've answered it really, really clearly. We've talked about the alpha, the beta and the gamma. We've talked about how no alpha is obviously being detected, and we've explained the 3 different sections shown on the diagram. So I hope you found that useful, and just to reiterate, it's really important to maybe set out your answer really clearly, not using loads and loads of words, using some bullet points, but clearly setting out in sections. We're talking about the front, the back and the side.